This is netstack.fm, your weekly podcast about networking, Rust, and everything in between. You are listening to episode 15, recorded on the 14th of November 2025, where Glen unpacks Pingora and Proxies at Cloudflare together with Edward and Noah.
Welcome for another week of netstack.fm. This week with me is Edward and Noah from Cloudflare. I am very excited about this one, as they are building a lot of nice infrastructure at Cloudflare, but one in particular we will discuss today is Pingora, which they open sourced, I believe, on the 28th of February 2024. They also recently had a recording in Rust in production, which was a very fantastic episode as well. There we learned that a lot of Pingora's history also comes from the lessons they learned in NGINX. We can also talk a bit about that. Now, welcome Noah and Edward.
Thank you. It's good to be on.
Thank you. Yeah, thank you, Glen.
So, as we have two guests today in our virtual studio, we're going to have two introductions. I would say, Edward, you can start as you were the first in the alphabet.
Great. So my name is Edward Wang. I've been an engineer at Cloudflare for almost 5 years now, I think. Prior to that, honestly, I was a software engineer at a game studio for a few years. Before deciding that I wanted to learn more about networking, and boy, did I jump into the deep end with Cloudflare. And so I sort of very much drank out of the fire hose in terms of learning. There's a lot of fantastic expertise at Cloudflare when it comes to, all sorts of networking topics in HTTP. And that's where I also was able to start working on Pingora, which I think the very earliest inklings of that started in 2020. And I've only technically, I guess, been working really closely with Pingora for the last few years. But in that time, it's been really rewarding, and it's been really great to see the open source journey. So it's a little bit about myself. Noah and I are actually on the same team at Cloudflare, working on the one of the components built in Pingora of our content delivery network.
Okay.
I'll hand it over to Noah. Yeah.
Yep. Well, I'm Noah, as already introduced. So I've been at Cloudflare for a bit over 4 years. Prior to that, I was in college. I have a bit of a history with Tokio and Hyper, especially the H2 crate. And I'm actually involved more or less depending on what time of year it is, or what year it is, with both projects to some extent. So and I've been involved with Tokio since actually before I was at Cloudflare. I have only been on the Pingora team actually for about a year now at this point. But prior to that at Cloudflare, I actually used to work on Oxy, which is the other Rust language proxy framework implementation that we have at Cloudflare, which is actually the one that is not open sourced, largely because Oxy has kind of historically been coupled to Cloudflare's infrastructure, and so wasn't actually open sourceable, but that has kind of been changing as of late. So, but yeah, I've one of the few people who's actually, I'm the only person right now who has actually worked on both proxy implementations at Cloudflare. So.
Okay, very interesting. There's already some things to unpack there, which I will do soon. But yeah, no, I mostly know you actually from Tokio and from Hyper. So I wasn't even aware that you work at Cloudflare. They did Tokio started before Cloudflare. That was, I guess, when you were still in college then?
Yep.
Yeah, very cool. Like, and then the hyper work, did that start because of Cloudflare or?
That started. So Tokio and Hyper have historically been kind of sister projects, and there's a lot of cross pollination with like the maintainer groups for both. And I got really involved with Hyper, actually through like Rapid Reset and other like H2 related DOS things that hit basically every like HTTP2 stack at once. And so I ended up basically finding my way involved with Cloudflare's like response to Rapid Reset, and then in particular like getting the H2 crate hardened, and like looking through like different DOS vulnerabilities in the H2 crate and like making that a much more secure and like much more hardened stack. And so like that was actually like kind of like a lot of my involvement with H2 and Hyper has actually been like kind of from like the security and like DOS side of things, of like finding ways to make it like like very, very hardened. Which it actually already like, the nice thing was like it actually was already pretty hardened, and it's a like fairly well built stack when it comes to DOS. Like when it comes to like trying to find weird ways to use the HTTP2 protocol to like mess with the stack and get it to like blow out some resource.
And do you think it was just like a sheer luck, or do you think there are specific choices that they made deliberately that
There's
resulted
some
in it?
stuff that was like, there's some stuff in there that's definitely where people were being very deliberate and careful and were choosing to use data structures that like might be slower in the general expected time, but would always be constant time over any input you gave. Like for example, some of the like certain things around how like HPAC, for example, is handled in that crate. There are some very deliberate decisions that were made to use constant time data structures, even if they're not going to usually be the fastest. Because there's no worst case, there's no worst case that like someone can take advantage of and exploit to like cause a server to like handle things in the worst case and blow out its resource usage. But a lot of it, I think, is actually just down to like writing idiomatic Rust gives you like, it turns out that if you do that, you have certain protections, not even necessarily for memory safety, but just like you're not trying to take certain types of shortcuts that you might take if you're writing C, for example, which is a lot less ergonomic of a language. And like some of the ways that Rust programmers just tend to do things with like channels, for example, lend themselves a bit better to like basically just not having these like weird split brain cases that you can take advantage of and exploit to like blow something out. And also like to like a slight amount of batch processing, which kind of happens in parts of the H2 crate stack, which like allows you to like debounce certain types of normally malicious operations and like make it so that they're not really a problem. So like, for example, with Rapid Reset, one of the things that Hyper actually like would do is it would take those header frames and it would take the reset frames, and in the parser it would just like basically read a whole batch of operations, and then it would look at like, and then it would like basically just cancel in the parser the request. And like it would not try to like, it wouldn't try to do any of these sort of like, oh, I'm going to queue up like a request task in the background and then like, oh wait, I need to cancel that, but it's already started. It wouldn't do that because it would just like read through everything and it'd be like, oh wait, but this is already canceled. Like I don't actually have to do anything. And like if you do certain types of like idiomatic Rust things, it ends up like resulting in code that is like a bit better and like a bit more well behaved from like a DOS perspective.
I see. Yeah, that makes totally sense. Thank you for that. And so, yeah, one question I want to ask, but is already like partially answered, is like I think you were first blogging about Oxy way before the name Pingora was ever mentioned in even like a blog post, or like, I don't know, like, or at least, or maybe I'm wrong there, but like what I mostly want to ask about is like, I didn't even know you were developing two different like proxy like frameworks, because I think what I want to say is that you were blogging about this kind of work, but I don't think, maybe there was no name mentioned. I thought there was maybe Oxy, but maybe not. And then Pingora came out, and I thought that was just the only one that you were working on. But now you mentioned that Oxy is still there, and then maybe my question is, how did that came to be, and then why still having these two like isolate from each other?
So this is one where I can give a bit of the history on that. So they kind of come out of two different projects that needed proxies that were very differently shaped for different things. So Oxy actually comes out of originally. So Cloudflare like has a thing called Warp, which is a like VPN-esque thing, which is actually also like our entire Zero Trust product line is built on that. Warp was not originally written in Oxy. It was its own thing that was pre-async Rust. And so it has that sort of like, hand-rolled event loop where you have like callbacks that you are dispatching based on equal events you see type of structure. And Warp required folks to try to solve a lot of problems on on Cloudflare's infrastructure that we hadn't historically solved and that are kind of difficult to solve on a CDN in a CDN environment. And then a couple of years later, so Cloudflare's like publicly blogged about like our involvement with a thing called iCloud Private Relay. We were involved with that, and we had to basically figure out how to solve. Like we had to redo where we had to apply our solutions that we came up with for Warp, to a very similar space, and we also then had at that point we're building out more things around Warp that required us to actually pull a bunch of those like solution code paths out of Warp and into other things. And that was for our Zero Trust infrastructure. And so Oxy basically comes out of like, okay, so we have a bunch of we need like a proxy framework that's like good for handling like basically like tunneled traffic, and allows you to handle things like geo egress, where you want to like, you don't want someone who's like ordering a pizza to like basically see that like, oh, like it says like I'm right now in like Dallas, but like I'm not actually in Dallas physically, I should say. But you might be like, oh, I live in Dallas, but it says that I'm in Ashburn, Virginia. How strange. And like the pizza, like all of the pizza stores are all like flagged for Ashburn, Virginia. Like that's not what you want. You want to have IPs that are geolocated, spread around, so that folks, whenever they hit wherever their ISP decides to land them, which can often be somewhat variable, they like, in theory, this should be our Dallas site, but maybe it's Ashburn. They should just see like the like stuff that's like nearby to them, regardless of where that is. And so like a lot of these problems around things like spreading out IPs, and like how to solve and how to handle that and how to like route traffic to the correct IPs was basically pulled out originally into Oxy. And now there's like a whole mesh of systems that this has actually been pulled out of Oxy and into, that are themselves built in Oxy. And so Oxy was like kind of originally came out of like folks looking at like, how can we handle this sort of tunneled traffic that's from like end users or eyeballs, as we tend to call them in the CDN world, rather than doing normal reverse proxying. And so like Oxy is not actually like, Oxy is not like, is kind of more used for forward proxying, and that was what it was originally built for. But it can also do reverse proxying. And like Oxy ended up being philosophically a fair bit different from Pingora. Like Oxy is a like super generic, like in the sense of using Rust generics very heavily, like is very built around generics, and it's very built around like handling as much in the type system as possible. And Oxy also tends to be like, it was historically like a huge mono framework. Like it was a massive thing that basically had a solution to every problem baked into it somewhere. You just had to have a machine that could handle the compilation time. Whereas I think Edward can speak a lot more to like the design philosophy of Pingora and a lot of the like problem space that it was originally built for.
Yeah. I mean, Pingora really came out of around 2020. Folks on the Pingora team, or I guess it was pre-Pingora at the time, we were just all in the sort of cache content delivery team, were looking at the problem of NGINX independently. I think we had talked a little bit about this on the Rust in Production podcast, but things had gotten to a point with maintaining our particular NGINX instance where it was really difficult to reason about a lot of different and custom code additions that we had made inside of the NGINX fork, and maintaining that alongside of, all of the upstream changes that were coming in from NGINX was really difficult because we were perhaps doing all sorts of strange things in order to optimize our caching system that maybe we shouldn't have been doing, or we were not aware that this, the lifetime of this particular object we were working with was not actually guaranteed to be this long, say, something like that. That was about the time when a couple folks I'd mentioned, for example, Yu-Chen Wu, our tech lead, had decided to go off into a corner and really try to work with the new, a brand new NGINX replacement, really, I think, was the main guiding problem space there. It was very much what can we do? What are the things that NGINX is maybe not as good at that we can learn from? I believe he was also working a little bit with Oxy as well from time to time, working on some of the projects there, and what are some of the different learnings and things that we can pull into a new framework, really. That was how Pingora started. Literally, I think I said on the other podcast, it started as the name, and you can see this in some of the source code still as Open Rusty, which is a play on Open Rusty, the Lua framework on top of, or a popular Lua framework on top of NGINX, right? And so honestly, it really honestly comes out of solving a really much more, I think, particular problem versus Oxy, it was made to also solve really particular problems as well, but as describing all of the things that Noah was talking about regarding tunnel traffic and such, whereas Pingora was really how do we replace our reverse proxy with caching, right? How do we replace our reverse proxy with caching and do it in a way that optimizes for a lot of our use cases, for example, origin connection reuse and things like that, in ways that NGINX is perhaps not as, or didn't really have that as its top of mind priority when it started, right? So, and from there, I think it's kind of, I believe that the folks at OpenResty were actually working with Cloudflare for a decent portion of time as well. And some of the older folks on the team were able to work with them too. I think a lot of that goal behind Pingora describes itself as a programmable framework, a modular framework. I think a lot of that comes out of OpenResty's philosophies, and at the end of the day, I think it was it really came to be. Here is a reverse, mostly having to do with a reverse proxy framework. Here is the engine for that. How do we make the engine as performant or ideal as possible? And then allow the user to sort of swap in whatever filtering logic that they want in and out. So I think of it as sort of a blank canvas on which people can inject whatever logic that they wish. It is pretty bare bones in that sense, I think, as at least as it exists today, because we have a lot of customized logic, and we work with all sorts of weird HTTP traffic, and we need to be really careful about which headers we add, modify, transform, when proxying from, different, like our internal stacks protocol to either H1 or H2 or what the origin supports. So having that fine-grained control too was also really important in terms of what we could actually, in terms of how the final product ended up being. So
Okay, thank you very much. Yeah. And you say bare bones, and in a way, I understand why, but at the same time, it does still seem like you have the foundations there, and it seems like you kind of like do hold the user's hand, as in it's not like they have to really make like a step-by-step, like how to put it all together. Like the engine is there, and you can, and in a way, it's not that difficult to make something yourself. I mean, you do have to read the guidelines, but in the end, it's just a matter of like implementing a certain trait and then you can choose which methods you want to override. Like, for example, maybe you want to add like a header or modify a header, which is very different than, let's say, I'm going to build a proxy with like hyper, where like there's nothing like that, and you kind of like have to figure it out on your own. And so I would say, like, I wouldn't call it bare bones, but I get what you mean. Like it's neither something like I have like an NGINX or like a open resty and maybe everything is already figured out.
yeah, it's something in between, right? It's something in the middle. And I think that we get requests on the reason why I think of it as more bare bones is maybe because we tend to get people who do try to think of it as an NGINX wholesale replacement, and like a drop-in, like ready to go, batteries included binary, which like it as you mentioned, it doesn't take that much to create a Pingora app of your own. There's a lot of the traits already available, and a lot of like that engine is already pretty much ready to go. However, especially when it comes to, as soon as you start doing, I think, things that are like slightly more complicated, such as like routing and stuff, you find that like location configs within NGINX, people really want things like that, right? And which makes sense. As soon as you start getting into things like that, I think people then realize, oh, it's really a blank space in that sense, right? In which you maybe have to do a lot of that yourself as it is currently today. So this is where we kind of, the lines are slightly blurred, but we generally want to defer that to the people, like some great community folks who build things on top of Pingora as well, in order to create the sort of more user-friendly routing configs and such.
Okay. And how would people, like, for example, discover these? Because I couldn't find anything like community crates or, I don't know, like external resources anywhere on the GitHub.
I don't know if we actively there, for a while, there was a project with some the memory safety org that we were working with, that was kind of the advocated, like, batteries included proxy built on top of Pingora, called River. At this point, I believe progress on that project is mostly paused. There were some other crates that I know of, that folks I'm not sure how well known they are. Perhaps we could give them a shout out in the README at some point. But I'm thinking about, like, for example, PingGap. There were some other, that is the one that comes to mind right now. I think there are a few others. But I'm also happy to drop those into the podcast notes too.
Another thing to me with like bare bones versus batteries included is like mentally I'm like comparing Pingora a lot to Oxy, and like Oxy evolved its own, like, well, not evolved, Oxy built its own, like, originally it was hard coded, it was just specifically Jaeger tracing framework that like nowadays uses OTel, like is now for OTel, but like Oxy basically like built out its own like entire like very opinionated telemetry ecosystem um that like has actually now been that part actually ended up getting split out of Oxy eventually and open sourced as a crate we have called Foundations. But like Pingora like doesn't like tended to like Pingora tended to go often with the approach of like taking a lot like what was out there in the Rust ecosystem and saying like, okay, well, like you can just use this with your like Pingora proxy, and like you can use tracing to do logging, or you can like do whatever, and you can use the metrics crate to like do like Prometheus metrics or whatever, if you want, and like whereas Oxy like built out its own entire like framework, and that it like doesn't is not even built around like tracing, for example, or even the log crate. It like has its own macros and stuff, and like pushed folks who were using Oxy to like use this sort of like all-encompassing ecosystem. It's kind of in some ways like the difference between like Linux and Mac OS in a sense. Um, where like Oxy is like you need to like be wholly vested into this like whole like sort of ecosystem that it like built, and things tend to work fairly nicely if you're within that, but like once you start wanting to step outside of that, you find that like, oh, it's like actually built not to not to be used this way. um Similarly, like Oxy, like, whereas like Pingora, there's a lot more flexibility and control given to the user. In Oxy, it's like there's a path that things flow through by default. And then like with Oxy, you basically have a whole binary ready when you just have a default app. Um you then have and then like what you do is you have to like specify via hooks. Like, okay, but like here's what I actually want my service to do in all of these different ways. Whereas with Pingora, it's like a lot more of it's a lot closer to like how folks who are building web services typically tend to think about things and tend to like expect stuff to work. Where you like have like a smaller set of handlers that you are invoking. And yeah.
Yeah, that's something I was going to ask around logging and metrics. So we can indeed link to the foundation. That's for Oxy, but as far as I know, that's not the case for Pingora. So like I was wondering there, what's the story there on metrics and tracing and everything? For example, how do you guys use Pingora and do the tracing and those things?
We actually implement that generally like the level above, like in our like in user space, so to speak. We implement things like tracing. Like there's some metrics and stuff built into Pingora, but with Pingora, like we also have a lot of other metrics we just collect outside of that. Pingora like uses like the Prometheus client crate, and like we use like basically like what's fairly typical in the Rust ecosystem. So Cloudflare uses Prometheus extremely heavily, and like Pingora is no different than most of the rest of the company in these respects. It's just like we tend to like do a lot of this stuff basically in user space, and rather than in like in the framework, so to speak.
Okay, and so yeah, a lot of developers like Prometheus. At the same time, like open telemetry kind of like became a thing, and like not I wouldn't say it's like a world standard, but definitely things are converging to that point. Is it like incentive for Cloudflare for projects like I don't know, Oxy to move?
So we actually use OTel for a lot of stuff. So like I mentioned Jaeger earlier. Cloudflare has like, Jaeger stood up internally, but we these days like what we're actually collecting is OTel, is like OTel traces, and so like we use OTel a lot in particular for tracing. Um, we don't yet use it. Like, we don't use it super heavily for things like metrics at the moment. And to be honest, I don't see Cloudflare moving off of Prometheus ever. Or at least not for a very long time, but like, cause it does generally work for what we do, but, like quite well. But, yeah, like I think OTel, like the big thing that's driven us to adopt OTel a lot more is like tracing and um, like that type of observability stuff, because like with metrics, with just straight up metrics, like Prometheus works quite well, but it's then when you like want to like dig into like more fine-grained things with requests, like you want to look through like what paths are requests going through like within your system, how long they're spending at different times, what like values, like what like flags were set for like a request in different like places, and like that's like what control headers like were present, like basically like internal IPC stuff that we have that directs how to treat this request, like what control directives we had set in different places. All of that sort of stuff is where like like distributed tracing is super useful to us, and like a lot of our like drive towards distributed, like a lot of our like OLTEL related like a lot of our OLTEL work internally has like to like onboard and adopt OTel has come from distributed tracing.
Hmm. Yeah, because like I was also gonna ask about like what if in something like Pingora, a request fails for some unknown reason, or a connection suddenly gets closed. Like how would you typically start diagnosing this kind of issue? I mean, not like there's like one generic answer, but still, I
Yeah,
wonder
well,
what
and
kind of the
there's
flow
a few
is. Yeah,
ways.
yeah.
So logging, uh, we have logging, we have metrics, and we have like distributed traces as like our general, and we also have Cloudflare is like a huge user of ClickHouse, and we have these like internal ClickHouse clusters for very, very aggregate like statistics around like requests where you can like with very high cardinality slice by things like CDN zone. Um, but so we have all four of those things, and like depending on like what type of issue it is, we'll look at different things. If it's like there's a customer escalation, like a customer's like, hey, there's a problem with my connections, like the big like they're like closing in this like way that doesn't make sense. It's like your routes to go through there are generally like a lot of like weird super anomalous things are going to get flagged into Kibana. Like if we're getting like protocol errors, like HTTP2 protocol errors or something like that, like that's, you're gonna like want to look in Kibana, and you're gonna see like, oh, like, and it was when connecting to this particular origin, and oh, okay, that's what's going on. One of the most commonly used ones when we get like these types of escalations though is like traces, and so like we have systems internally where we can like adjust the volume of traces we'll generate, like for like what proportion of requests will like generate traces for, and then we can also just like create a request like do effectively the equivalent of a curl command, and we can just basically say like, yeah, we're going to do this on this particular server, um or any server in this particular site, and like we're going to run this effectively a curl command, and it's going to give us a guaranteed trace that we can then go in and look through. And so like you can use this to like really like you can use like distributed tracing to like really understand at a very like fine-grained level what exactly is going on in different parts of a request. And so like it's kind of a combination of those where we slice and dice, or like we pick which ones we're using depending on what the problem is. A lot of the sorts of issues that I often end up looking at, and that like I've kind of specialized around debugging, often tend to be like very resource related issues, or like traffic management related things of like, we're lensing a bunch of traffic, in like we're lensing a whole bunch of traffic, into this like like small set of like servers or this one site. What's going on? Like, how can we spread that out more? And for that type of stuff, I tend to use Prometheus extremely heavily. And so like, like the number one thing I tend to look at myself is generally Prometheus, but like Edward, for example, is a much bigger user of things like ClickHouse than I am, because Edward like often looks at a lot of these like very, very like what's going on with this zone or with this type of traffic issues.
It's a very, yeah, we have a lot of different metrics and ways to slice and dice things, because when it comes to analyzing issues, there's often heavy hitters, right, at Cloudflare that are causing those issues. And so we want to figure out what exactly is the kind of traffic. And so we have that is causing these issues, and we have different ways to slice and dice that via the different data sources that Noah was talking about. The other thing, I mean, this is really top of mind in terms of debugging observability, because like I think we were very much more in the dark, I would say, with NGINX, because there are cases where we were deliberately trying to be a lot more verbose and trying to inject hooks into like what errors, connection errors, as you mentioned, would come up either on the downstream side or the upstream side. Either on the client or server, I suppose you can think of it, because either one of those causes problems, and everyone turns to us, right, and asks which remote end hung up, and we have to be able to answer that. So those error, like for example, the error while proxy hooks, very deliberate decision.
Okay, makes sense. And yeah, I also want to I was first wondering okay, let's get an overview of different crates, because in Pingora there are many crates, but then I noticed the README already does quite a good job on describing the general overview, so I'm going to link to that instead. But then there are a couple of crates in specific where I have some questions about. For example, like the Pingora Ketama, that one, I would have no idea what that is about.
There are a lot of different. I think that the shape of the repo and the kinds of crates that are in there kind of give you like some hints as to what are the particular things that our team perhaps cares about. For example, probably the place where we're really most opinionated about inside of the proxy framework is actually all of the different caching hooks and filters and stuff. And I mean that within the actual like Pingora proxy crate itself. We tend to be a lot more opinionated about things in those contexts, because caching HTTP is really specific, and it is something that our team in particular really cares about. To that end, for example, as you mentioned, Ketama is as part of switching over from NGINX to using Pingora, there are actually a lot of different components inside of the CDN proxy stack, you could call it. And so we wanted gradual deployments, gradual migrations. We wanted to be able to swap these components in and out. One of the things that is a problem, maybe, is if you change. We actually we do consistent hashing when it comes to selecting certain, where we should go to, for a certain URL. Maybe we should go to a different server backend, right? And if you decide to change that in the process of migrating from an NGINX component to a Pingora component, that's not great, right? Because all of a sudden, if you are doing that migration, maybe you're going to change where your backend URL, which URL your backend you choose. Sorry, which backend you choose for a URL. Which will cause you to have a cache miss, essentially, right? Because you're suddenly going to a different backend than the one you were going to before. So Ketama is one example of a consistent hashing algorithm that we re-implemented in Rust in order to make sure we had parity with the logic in NGINX. So all of that, I think, comes out of the shape of what are the things that we tended to care about: caching, with caching, in caching backends, consistent hashing, and things like that.
Okay. Well, yeah, I see a lot of things around caching and memory caching and those things. But like, oh, I mean, I guess you cannot keep everything in memory. So if it's not in memory, where do you store it then? Like, I suppose not on a file, but maybe like on something else. Like what is the maybe? I guess what I'm wondering is like, what is the typical structure at Cloudflare for like the layers of storage?
Hmm. Sure. Yeah. I mean, a lot of the caching occurs on, you know, disks. Like when it comes to actually like holding people's assets, we can tend to cache really large files, right? Where we're dealing with videos, you know, not just tinky little HTML files anymore, maybe AI models, right? So so obviously a lot of that stuff gets put on disk. The memory caching crates and things that you were alluding to within Pingora are actually for things where we're, say, looking up certain configurations, or we're caching certain like configurations that we need to look up, because maybe some other team service is responsible for those configurations, say like with how we authenticate with the origin, for example. What kinds of like TLS certificates should we be pulling? That kind of stuff is for the memory caching, and those little like tools that we can kind of cache certain look aside things that we need to do in order to serve traffic. So definitely not for the actual like there's like the HTTP caching proxy built into the Pingora proxy crate, and then there's all of the various maybe look aside operations that you need to do, which is where the memory caching comes in.
Okay. And the HTTP caching, that's, I guess, all based on all the HTTP headers and all those kind of things like e-tag and expiration dates and all that kind of mess.
Yeah, if you look at there's actually quite a extensive default implementation of like cache control parsing, for example, within Pingora, within the Pingora crates. It's very like it literally came as a result of me studying RFCs for a few months, and one of the first things that I was doing at Pingora. So as I mentioned, those parts tend to be really opinionated, a lot more so than the rest of the proxy filters, which are just, what do you want to do with the request filter? Do whatever, or what do you want to do with the HTTP request? Do whatever you want to it, right? Yeah.
Okay, very cool. And then, yeah, I saw that like a lot of these crates are like very like small, and like a lot of the logic seems to live in Pingora core. And then while I was going through the code several times in the last years, I also noticed sometimes patterns, and one pattern I sometimes see there is like that you use a lot of like OnceCell, where I see like, okay, you're like having to get some information from a socket and then you put it in like a OnceCell. Is it, I mean, I have not seen this pattern that often in other like libraries. Is it something you just, I don't know, there were performance issues and you noticed this helps a lot, or like what is the reason behind that?
If I think about, you might be thinking about for like certain APIs to grab, say, like the local address of a socket. I think um, the I think the reason why we do some of those things is that as much as possible, we try to make it so that the user doesn't have to pay for things that they don't have to, or that they aren't necessarily using. So if they're, for example, grabbing, maybe it's the peer address, maybe it's the local address. One of them is actually already available on the Tokio when Tokio accepts. Whichever one isn't is probably the one that we're thinking of. And that
The
is
local address. Local address
maybe
is
it's
what
local.
we'd be
I think it's
grabbing.
probably local. Yeah.
Yeah, yeah.
So that
Okay.
one is lazily instantiated because we don't want to. It's essentially, I think NGINX actually does the same thing, where the first time you actually eagerly try to look it up, you will then essentially cache it within whatever struct you're using. And taking inspiration from that, we did a lot of the same things in that situation, because if you don't actually care about that address, we'll try not to make you do the extra syscall in order to use it.
Yeah, makes sense. Okay, and then, as you said, there's a lot of strong opinions there, and so around caching, I get it. But then, what I was surprised by is how many TLS-related crates there are also, because you have boring SSL, OpenSSL, Rust TLS. I mean, those are the obvious ones, but then the one that surprised me is like S2N. Like why that one?
That one was
It's
actually
a recent development.
Yeah, that one was actually a request from some folks at AWS, because that is that is the TLS implementation that is apparently very heavily used in, I guess, parts of AWS's stack, and they were using Pingora for some things, and they really wanted to be able to use their like S2N TLS implementation with Pingora, and so they contributed that in a pretty sizable PR to add that support. And so that one, as well as like Rust TLS, were both like user contributions. Within Cloudflare, we use boring SSL across within the company, because basically we have to be FIPS compliant. We have to be compliant with a standard called FIPS, and boring SSL does have FIPS certification, and so that is kind of like the thing that you sort of have to use generally if you want FIPS. And so like we use boring SSL very, very heavily within the company. And so like generally like in most Cloudflare stuff, you're going to see like a boring SSL support option.
Yeah, but then again, I was under the impression, or maybe it was just my wild dream, but I was under the impression that FIPS was kind of like disappearing and no longer want to be a thing in the near future.
Unfortunately, I really wish it wasn't. To be honest, I really wish FIPS went away. That's me not speaking for Cloudflare at all. That is just me personally. I don't like FIPS, and I think I don't really like it. But
personal
I
opinion.
don't think, I don't think it's going away, unfortunately, because there's just so many. I don't think that it leaving federal contract requirements, and thus like flowing downstream to like, people who like provide services to the U.S. federal government, like also then need FIPS from their vendors. I don't think that is changing, unfortunately, anytime soon.
But they are kind of like stuck in very old standards, no? Like very old cryptographic algorithms.
Yeah, the thing with FIPS is that this just means that you have to have FIPS algorithms in there. And you have, okay. For something like a library, you need to have a FIPS, let's pretend there's a magic stamp that says this is FIPS. You can add additional things that aren't FIPS, but it's not FIPS that traffic is now not FIPS when you like use those. But you can still have them in the library. And so like with boring SSL, that's the case. Or like there's like FIPS algorithms in there, and so like you have to, like, if you want, to like, we can speak non-FIPS ciphers, but that's not FIPS. When folks like speak that to us. But if someone like speaks to us with FIPS like if a client speaks to us with FIPS ciphers, then like we're now talking FIPS, and it's like a like certified like FIPS it is a certified like FIPS like connection now. And so like you can use just the FIPS subset, or you can like use non-FIPS stuff. I will also say FIPS FIPS is not insecure the way that it used to be. Like they do roll new cipher algorithms into there, and there is stuff that is like, there is stuff that it like if you're using FIPS these days, you are hopefully, I would really hope so, using the stuff that's actually like very recent and very cryptographically secure that's in there, and is like basically effectively normal, like still pretty normal TLS. Or like it is like normal TLS, like you've got very bog standard normal TLS stuff that's all FIPS, and so like it's not, you're not really using like stuck into using old ciphers anymore. And then also even with post quantum, you can still do that with FIPS. It turns out that like the approach that us and everyone else is mostly doing with post quantum of like having a sort of an onion thing where either you do like a like second layer of post quantum after the normal layer, or you do post quantum first. Like that approach, because one of the two layers that's happening here is FIPS, that approach is actually completely fine. You can totally do post quantum with FIPS. FIPS doesn't, what happens is just FIPS like doesn't acknowledge that there's any security guarantees from like the post quantum bit that's not FIPS. But like in the real world, it's like we know that like, okay, we've actually just made this post quantum safe by doing this. And so like, yeah, like that's actually another thing that folks are pretty interested in doing, is like having FIPS and post quantum together. So
Okay. Okay, yeah, that makes totally sense. So, but then, like, I wonder, okay, those users contributed as TLS and they contributed S2N, but there are plenty others like KTLS, S-Channel, Libri, SSL, Wolf, whatever. If a user wants those, do they have to contribute upstream, or they can just in their own, like, is there a way for them to hook it into?
Complicated. They would have to contribute it upstream. Part of this is there is not a standard, like, there is no standard SSL API. I want to throw a massive asterisk into this, which is that in some ways, boring SSL, if you squint in some corners of the, like, depending on how you're using TLS stuff, boring SSL kind of sometimes is the closest thing we have to a standard for, like, how SSL should look, at least for certain things. Many asterisks are attached there, but there are a ton of different SSL implementations that all do a lot of things differently, and there's no like standard, like there is not for, especially if you're trying to do cover every case, like there is not a standard like TLS like SSL library API. And so like it kind of has to be like, users have to add their own, like people have to contribute it upstream, because like we can't like there's no way that we can talk to every single one of those, because they have just completely different APIs for how you do all sorts of operations.
Okay, I understand. So it's because you have a set of operations that you want to do, and they are configurable in Pingora, because it's kind of like because that's why I meant it's not really like a bare bone, in my opinion. It's very like opinionated, and it's like an engine which, if you're on the happy path, it works for you, because you have all these hooks and all these ways to use it. But that means that you cannot just, as a user, add whatever you want, because it has to kind of like hook into the system, right? And so that's kind of like, it makes it easier to use, but it also limits those use cases, I guess, which I guess is fine if you're AWS, you can just upstream it, and I guess you're more than happy to accept it. But I suppose there's also a limit. Like, I don't think you will want to have all SSL implementations in there. That would probably be a nightmare.
Probably not. Yeah, we want to do, we have it such that these SSL backends should be feature configurable. You're generally not using more than one of, it doesn't really make sense, I think, to use more than one TLS backend at a time. So they are compiled on configurable. We generally probably will, maybe there will be other TLS backends that we're interested in accepting, like if there's popular, if it's significantly of interest to someone, that would be, I think that would be fine with us, to continue accepting these things. We do want to make it such that, like, if you want to use something different, he would like you to be able to swap it out, because we, see that kind of usefulness and that kind of freedom for ourselves too. So
Okay, and then what is also not clear to me is like, okay, you need tight control. You're a proxy, so you have to be very careful in the traffic, because you could easily break it. But then I wonder, what do you use for like the HTTP like server and client logic? Is it Hyper? Is it like the core crates? What is it?
So
it depends.
we
Okay.
mostly we use so for HTTP 2, we use a fork of the H2 crate. That fork is like pretty close to standard. Like the difference is like we have to be able to speak to things that speak horrifically, to be honest and blunt, horrifically broken, extremely like non-standards compliant. H2 should not support this. HTTP 2. Like, because yeah, and like this is the thing is it's like there turns out that there's like a lot of like clients out there that are actually in our or origins in this case really like origins out there that are horrifically broken in their support of HTTP2, and H2 is a lot better than H1. Where H1 you kind of like for something like us you need to be maximally permissive because of just how much stuff there is out there that just is like this is not how you should be doing this, but it's been how many decades at this point, and there's just so many different weird things that turns out you have to handle because some like giant customer is complaining that you can't talk to their mail server or something. And for HTTP2, there's a lot less of those, but there's still a lot. And we still see things like regularly popping up of like some weird thing where you're looking at it and going, okay, like the RFC actually straight up says you should reject all of these with a protocol error. And you're like, but like some enterprise customer will be like, yeah, but like, you know, like I'm going to make up an example, like Microsoft's mail server or something like does this, and you're like, yeah, great, lovely. I guess we have to like accept that. And like for the H2 crate, it doesn't really make sense. Like the H2 crate is kind of targeted at much more typical use cases. And like for that side of the thing, you kind of actually want this. Like you want to be like a bit stricter in like what you will accept and like what you will work with. Whereas for something like us, like we need to handle just a lot of these like weird, stupid cases. And so like we have like modifications in the H2 crate, but like we upstream a lot like stuff that we do, and we like pull in like changes in upstream. And so like we actually like at Cloudflare have a pretty good relationship with Sean MacArthur. We like work with him a lot. Like that's actually how I got involved with DOS related stuff in the H2 crate. Whereas with H1, like H1 is a lot more custom. Edward, you can speak to that a lot more.
Sorry.
No worries.
Yeah. As Noah's mentioned, we publicly, I think we don't have a patched H2 and used in Pingora. Like it is just some of the H2 primitives that we're like sending and receiving with. The H1 they're like it is also very closely tied in with I guess like on the connection level and the protocol level, we're working with the raw bytes themselves oftentimes, and it's not actually that it wasn't, at least when we first developed Pingora, also that complicated to consider implementing that. It turns out H1 is actually very much a minefield, by the way, though. It looks simple. It's a textual protocol. It looks like plain text, but there are all sorts of footguns you can run into because of its connection state management and things like that. But we do actually want that sort of control over like what is happening, or we want to be able to see also and control that behavior of what's happening on the connection level, ideally if possible too. Some of the things also because of the customizations and things we are talking about, or that Noah was talking about, like we oftentimes, maybe sometimes, would actually prefer if we had more of like a lower level view of, say, what's going on the H2 connection than what the H2 primitives surface to us. So likely, whatever we do with H3 in the future or something like that, we would probably opt to do something a lot more like working with the protocol on a more primitive level if possible. That they're actually will probably honestly be using the some of the open source Tokio quiche crates that the protocols team at Cloudflare has worked very hard on, and rightly so. So yeah, I think that so the answer is it depends. We have H1 that we kind of hand wrote in a lot of cases, and then H2 we piggybacked off of a lot of the hard work that Sean did. So, but quite honestly, we do. Having that control on the protocol level is important to us. So we'll see what how the implementations change in the future. But yeah.
Okay, thank you for that. And then I also saw that you have like gRPC support. I wonder why that is.
Because we have gRPC support because that's actually a thing we have to proxy not infrequently. There's a lot of people who put gRPC things behind Cloudflare, and so we have to be able to speak gRPC, and we have to be able to proxy that through and make that work. And so
there's actually a big
yeah.
blog post on that too that describes what are the strange ways in which we've had to transform our internal traffic into something called gRPC web in order to be able to proxy that to origins.
Okay, very nice. Well, we also had an episode about gRPC, and there also it was about gRPC web and all those things. So listeners can listen to a past episode about that. But okay, that makes totally sense. Is there also caching required for that kind of traffic?
No, almost certainly not.
That's gRPC is one of those things that is pretty much always what we call dynamic traffic, which dynamic traffic is a fun thing because it is stuff that's not cacheable. It turns out if you know something isn't cacheable ahead of time, there's actually a lot of interesting ways you might want to treat it. One of the things that the first application of it so far has been, okay, well, how do we fan in and lens in traffic for a given to a given origin to the smallest set of machines we can within a site or a metro, because the idea is if we want to give you really good connection reuse, we don't want to be creating connections from every single machine. And so what this basically does is it looks at us at we for example can do things with dynamic traffic, we can say okay, well, we don't need to take a hop ever to another machine to check if it's in cache or not and incur the latency hit there. Let's take that little spot let's take that little spot and let's do a hop to a machine that we're pretty confident is going to have a warm connection pool. And so one of the big traffic things that's going on here is we're looking at cross our machines, okay, well, let's assign these let's assign the origin connection pool basically to this machine or this set of machines if it's a giant zone, some sort of popular zone that's going to have just a lot of traffic. You might put one of those on that you're that's going to need to be spread across a few a number of machines for load balancing and just keeping resource utilization, that zone slice of resource utilization manageable. But you can basically lens things in to get really good connection reuse. And so for dynamic traffic, a lot of the work that we've done over the years on dynamic traffic actually tends to go along the lines of okay, for this traffic, we're actually extremely sensitive to connection reuse. And so there's a lot of even some interesting historic hacks that we had back when we were using NGINX around like getting around like improving the performance of dynamic traffic by improving its connection reuse. For example, like NGINX has this interesting behavior whereby you have a separate connection pool per worker. So if you have like, 16 cores, for example, that's like 16 different worker threads, each of which has a completely distinct connection pool. So you're going to get often like really bad connection reuse. Um, but a way, for example, that we used to back when we were doing origin requests from NGINX, way that we used to like improve this was we would have like the big NGINX like caching instance, and then we'd have this tiny instance that like only handles the uncacheable traffic, and like basically and like the like those uncacheable requests. We would basically send to like the smaller NGINX instance that only has like a fraction of the number of like worker threads, like worker processes that like the bigger one had. And so like that smaller one would give way better connection reuse. This is the sort of hack that is not necessary when you're using Tokio. Because if you're using Tokio, it's like, great, like I have nice, like this like work stealing thing. Like I have this like nice work stealing thing there. I don't need to like worry about a lot of the performance issues that you have when you're trying to do shared nothing, where like you're like, oh, all of my caches are split between all of my like isolated instances. Oh no, or all of my connection pools are split between my isolated instances. And so like we could just like make this sort of thing work really nicely and easily. Um and magically when we like basically it's like when we switched over from origin fetch being NGINX to being Pingora, we just had this like massive performance improvement overnight for connection reuse that really positively impacted a lot of like these like dynamic traffic heavy workloads like gRPC. And like now with Snowball, with like fanning things in more, we have like another huge improvement. And like these are the sorts of things that like one of the big things that's been nice about Pingora and like Rust versus trying to do everything on top of NGINX is we can bake a lot of this sort of smart logic into our proxies that we couldn't really do with NGINX that easily. And so like we can ship these like really impressive, really interesting features and like bake all sorts of cool stuff into our services with Rust and Pingora that we just could never do historically.
Okay, I get it, but then like I cannot even count how many times you use the word like connection reuse, and all that is around like transport layers. And so I wonder, and that, I mean, why do you even have to care about the application layer? Can you not just like do it purely on a transport layer? Maybe you have to peak sometimes on what kind of traffic, but I wonder like what's the importance then to actually decode and re-encode the gRPC data?
I mean, like, what's like the cost of that for? I mean,
it seems like a lot of work to just anyway like proxy it.
Oh, well, because like a lot of times what we're doing is like any other traffic at Cloudflare, we're applying like security related, like we're doing security related checks. We're doing like some sort of like, like providing DOS protection, or we are like web firewall, like web application firewall type stuff in there. But also with gRPC and dynamic traffic, it turns out we're actually also in a really good spot to like accelerate performance with that and make things faster just by sitting there and by doing things at layer 7, because like, we can like basically like we have this giant edge network, like eyeballs. So like end users will basically like, or like services that are like reaching out to some origin will hit us from around the world and all of these different sites. And then like we can do things like we can find like the fastest paths basically through our network and like substantially improve the like origin fetch performance, because like public internet routing is not necessarily very fast. You can do lots of like, there's a lot of like weird tromboning and things that happen just because of how BGP works. And so like by doing a lot of this sort of stuff internally, we can accelerate things a lot, like even for these like dynamic traffic use cases. But then also like it turns out that like this sort of connection pooling from like, somewhere that's like really like close to the eyeball, all the way out like through to the origin, like, and like the way that we can hide round trip times with like basically like all of this connection pooling and like improving connection reuse, we can also just get like a massive speed up from that. And so like a lot of the reason that folks use this is like often for like security or for like all sorts of different like, product like more typical like product use cases, but like people also get like a giant speed improvement. And like there are some customers where like that is actually specifically what they want, is like accelerating their performance in like one way or another. Dynamic traffic is also interesting because it's like increasingly a large share of what people really care about, because historically, like if you think about how the web historically operated, you had a lot of static assets. In like the web 1.0 era, it was basically it was almost all static assets. And then web 2.0, like things start shifting a lot more towards being dynamic, and like this is a trend that like we've kind of seen just picking up more and more over time, especially with like AI traffic picking up as an increasing thing. Like that AI traffic, as it turns out, pretty much entirely dynamic. Like most AI related traffic, for example, is dynamic, and like a lot of like growing use cases, like not just AI but just generally, are all like really, really dynamic traffic heavy, and like involve a lot of like API traffic and a lot of stuff that's like, all like post requests or like get requests that are never going to be cached. And so like a lot of those cases where like a lot of our users are like a lot of those things that our users are increasingly doing like are often less and less cacheable. And so like dynamic traffic has become like a like growing focus over time of like what are all the things. And so like we've like a lot of like there's a lot of work that we've done that's like, okay, well, like what are ways that we can actually make this a lot faster and make this like this type of traffic a lot more performant than it normally is. So
Yeah. I
Okay.
also wanted to just get at your point though too about like encoding and decoding as well on the application layer. Like we can really leverage. Cloudflare has a really impressive network that we're leveraging in order to do a lot of this acceleration and that customers pay us for, right? But sometimes when it comes to like the one of the reasons why gRPC needed to be converted to gRPC Web to begin with is because a lot of like legacy components didn't necessarily speak that, right? And so when we're actually proxying from different components within our network or different services within our network, really, that is, we need to do these sorts of translations sometimes. If you were just simply like L4 proxying it, that, in theory, you could do something, or you would get this sort of similar benefits of utilizing the network, right? But for talking to the different components, or sending that request through different parts of the stack that maybe only speak HTTP1, then you need to be able to do these sorts of things on the L7 layer.
Okay.
Maybe unfortunately, right?
Yeah, I mean, I just wondered in the end there are like, it's nice you can do it for gRPC, but then there are like a lot of protocols and there's no way you're going to ever support all of them.
Sure,
So
yeah.
in the end,
Yeah.
there are limits, but yeah, if it works out for gRPC, why not? It can
There
only
are
be good
other-
for the users.
Yeah. And I mean, there are other like sort of L3, L4 like proxying. So we, as I mentioned, we're really focused on the traffic that ends up going through like HTTP traffic, essentially, that on our team, really. But there are we're actually relatively our infrastructure is really important to Cloudflare, but our product and the services and the traffic that we work with is also not the whole, certainly. Yeah.
Yeah. Okay. And then, as far as I know, it's purely built on like Tokio for the async runtime, and it's quite known for like the fact that by default it's often used in a work stealing mode. But then I saw in Pingora runtime that you have something like, okay, you can configure like no steal and steal, meaning no steal, like you have like probably like a runtime per thread or something. Like, is that something that you guys utilize in different ways? Do you always use one of them, or?
we
We
always use work
actually
stealing, except for Actually, Edward, go ahead. I know what the specific case you're about to talk about is.
Yeah. No. I mean, I think that the no steal flag that you're talking about in particular was really something that we were trying to experiment with for a bit, and seeing if you would get. I mean, the kind of motivation behind it is that work stealing comes with some, inherently by design comes with some overhead in terms of thread coordination, right? But when we looked at what the actual, because we have various ways we can deploy things to various sites and test things out. Oftentimes what we found was that the no steal runtime wasn't actually giving us the same sort of any sort of performance gains that we might have expected, or any reduction in that overhead, because it turns out that Tokio is actually very, very well optimized in order to make that overhead as low as possible. And when you're dealing with having not all requests be equal, oftentimes and maybe even requests in the same connection, you do often want to be spreading that around or distributing that around to different threads in order to make their load more equal. The whole purpose behind that.
Okay, yeah, that makes sense. But then, I noticed, for example, in one of your crates, Pingora header 30, I think you kind of hinted at that crate a bit in some previous explanation when you were doing this live of a request kind of story. I think at some point you touched on it without mentioning the name, but in there I saw usage of things like thread local, and then I wonder how is that useful if you're also doing work stealing, because you kind of you're no longer in control in what thread you are, right? So I wonder how is that then used in there, or is it not?
I believe that thread local in that case is it's not often that we use those sorts of things. In that case, I think it was really specific to Z standard compression, decompression, and that a thread local buffer that we use in that case, because in that we're also, I believe, not I don't believe we are have async await points between that either. Basically each thread in those situations, it doesn't necessarily make sense to have a shared, for example, a shared buffer or a shared workspace between those threads to decompress, to do compression and decompression. When it makes sense, I think that it having that per thread workspace makes sense in that situation. The really nice thing with Pingora generally is that we often and Tokio is that we don't often have to think about that, and when in cases where when we're actually want to be coordinating things between threads, it's actually really easy to do, to have a shared cache that isn't sharded, for all the reasons that we mentioned before. So I think that's very particular localized function there.
Okay, very cool. In that case, I think I asked most of the things I wanted to ask. I wonder if there is anything that we didn't discuss yet that you think we should plug in, or that you want to still discuss.
I was gonna say one of the biggest. You kind of touched on it with work stealing, with discussions of work stealing at the end, but one of the biggest performance improvements, not just with Pingora, but across Cloudflare stack that we found, with switching just a ton of things to Rust, has actually been Tokio and work stealing, because at Cloudflare, we have a lot of institutional experience with shared nothing and trying to do performance engineering on shared nothing environments. And one of the things that we've kind of learned very heavily over time is shared nothing is actually a really terrible fit for most use cases. And one of the big like interesting things that we found with this is just like there's like shared caches, it turns out, is like that, like, or like things where there's some sort of affinity, like performance affinity, where if this thing is pooled across a whole bunch of like units or instances, like things get faster. Like that's a common case, but like one of the biggest things is just like it turns out that like trying to balance load like at like the sort of micro scale that like latency stalls can be introduced at across a bunch of shared nothing like instances is really hard, to the point that like actually like to some extent, like depending on what type of traffic you're serving, it's actually just often not possible to do within the bounds where it will become a problem. And so like shared nothing, like one of the big things that like we've had to like that we found increasingly is just like moving to Tokio means that like we can do things like, for example, like run a single instance a lot hotter before we start to see tail latency go up, because you're not really bound by like the worst performing couple of cores at any moment in time. Like work will be spread out. Um, and so like you can handle like a lot more, like you can handle things like asymmetry and like things like asymmetry and like how expensive requests are, for example, quite a bit better with work stealing. And so like there's an interesting thing where oftentimes it doesn't really matter if you make things slightly slower on average, if you can like better spread traffic out and better distribute traffic, because you actually do just get a lot of savings from doing that. And then also like it turns out that like work stealing makes it easier to do a lot of things that like like connection reuse that like have a very real impact on how fast like people's like traffic is, or like actually like loading config, for example, is like another case where like there's a lot of like per CDN zone config, for example, that we have, and like if you have a like per NGINX worker like cache, it turns out that like you are going to have a very high miss rate. And if you make that not a per worker cache, and if you make that like a shared cache, that like in memory for everything, things get a lot faster magically. And you also get to save a lot of memory because you don't have to like massively oversize all of these caches to try to eke out a bit more like cache performance. And so like there's a lot of these sorts of things where like we found that like it makes it a lot easier to like it has like like just the like writing idiomatic like Rust and just using Tokio makes a lot of our like stuff so much faster and like more effective than when we were dealing with NGINX.
Yeah, I mean, you don't have to convince me. That's also been my experience. But like, I ask mostly because I don't know. Like, I've been using Rust now for so many years already, and every now and then you see these things flare up. Like, oh yeah, work stealing, non-work stealing.
And that's part of why like I bring this up, is because like it's like, as someone who like, you know, Edward and I both like maintain one of the highest traffic Rust language like services out there, and with like our Pingora services, and like kind of like a lot of these, like it's interesting to go like going through and reading them can often be annoying, and like I've wanted for a long time to like write up like a Cloudflare blog post on like what we see, for example, and like what like we like types of things we notice like performance wise, and like do some sort of like A/B testing on like parts of our fleet, like in like corners of our fleet. But the like one of the things that always like comes to mind is it's like, well, like we have all of the like I see like and regularly interact with so much data around like how like how these sorts of things tend to perform at scale, and like also like under all sorts of just radically different traffic profiles and things, that like I think like a lot of that sort of like discussion around like, okay, but like what do real traffic patterns actually tend to look like, and like what are different real traffic patterns that pop up, what happens when you start mixing them together on the same multi-tenanted systems, what happens when they're all isolated and individualized, and like what does like and like how do these sorts of differences in usage like lead to different performance outcomes? Like I think a lot of that is often what's missing, because like a lot of the shared nothing versus work stealing conversations are like, how does this how does this work and what's better or not? And it's extremely in a vacuum and often very divorced from like, what does traffic tend to look like? What does load often tend to look like? And like, how are those things shaped? And like, what costs often do they incur on a system? And then like also like, how do these sorts of things often manifest as like tail latency? Like, and I think like a lot of that is often like what's frequently missing from conversations. And like what I think is like a lot of times is like the much more interesting story is like, okay, well, like what are the cases where shared nothing actually performs better, and like what is special about those cases? Because like what I found is like there are cases where shared nothing is better, but they're all like really interesting, really special little use cases that are super cool. And a lot of times like the like interesting story there is like, okay, well, like what's unique about this that like causes it to work a lot better? Which is always like super cool and interesting.
Yeah, I mean, even then, I guess people can just mix the two also a bit. Like they could
Oh
just
yeah,
devote
totally.
a thread to just doing that, and
Mhm.
yeah, I mean that's what I would do when I need to mix those two. But
Yep.
yeah, I also think it's because like I guess our experience matches, because I mean we're also both doing proxies, and so I think I think especially in proxies that's definitely something where work stealing helps a lot. At least, yeah. I mean, what you say, where it makes a lot more sense to share all that kind of stuff. Okay. By the way, is there something you also do around like reuse of like memory to avoid allocations, as you are like dealing with a lot of like traffic? I mean, do you use like things like ring buffers or allocator, bumper, whatever?
Depends on what the like depends on the like what we use a lot of different things in a lot of different places. But like the interesting thing is like one thing that is pretty consistently done across most of Cloudflare stack is use gEmalloc. If you're familiar with that allocator. And one of the
Yeah,
interesting things about
for sure.
allocators is like a smart, like modern optimized allocator is actually already like automatically doing for you a lot of the tricks that people often like think of and try to do to optimize their own performance. Um, like for example, people will sometimes be like, oh yeah, well like I have like a thread local where like I store buffers, um, and I just like look up against a table of like what size, like what of these like standard size buffers I'm like going for, and I pull from that. And it's like, congratulations, a lot of allocators do that actually for you. And so when you call like the allocate function, like that's actually just happening for you right there. um, and like that's like using like a like not default glibc allocator is like actually one of the like, I would actually say by far it is the most impactful generally like memory performance, like or like memory allocation performance improvement. Um the like and like jmalloc is again like what we tend to mostly use at Cloudflare, like, but like there's a lot of allocators out there, and like there's a number of ones that are like very well adapted to specific use cases. And so like this is one where like I think it's actually like really, it's a really good idea often to like experiment with a few and like sort of evaluate how that performs on your production workloads, and like, or in your particular like use cases, like what are the performance of these different ones, because different allocators can be optimized for like very different like use cases. And so like, yeah, like using like a like good memory allocator that is not the default glibc one is often like yeah like is often like a like huge can often like give you a pretty significant like performance improvement. um we do have some things where we do like ring buffery type things. There's also like a lot of like BPF related cases where like when you're writing eBPF, how you do like management of a lot of things is very different. eBPF, you also don't like you're writing like very bare bones, like it's kind of like embedded systems, but even more so where you don't really like you don't have a heap, you have a very limited set of stuff at your disposal. And so like BPF, just like how you interact with buffers is often quite a bit different. But I don't know, like ring buffers specifically, it's like there are cases where sometimes you want to use that. But like I think like I would say like across the board, like the biggest thing that we do is just use use JMalloc or like another like modern allocator that like handles in particular like concurrent workloads very, very well. And so other things with memory like that are useful that we do, there are a number of cases where like I would say like I'm a person who uses like small string optimization and like arc str all over the place a lot of the time, depending on what I'm doing. Like those sort of like heap allocation reduction tricks are used a lot. The like
Yeah, that
avoiding
was
like
what I was going
yeah
to mention. That seems to be the main thing that we control on the
yeah
app, like on our layer, um, aside from, being smart about allocations generally, but um, like yes, we're trying to be smart about not copying like a bunch of bytes around when we don't need to. Uh, our, it all comes down, a lot of that just boils down to essentially a glorified arc in a lot of cases.
yeah. And like in a lot of my cases, like I I have some like when you're doing distributed load balancing, you're trying to like schedule traffic around, like you often find that like you care about like the compute cost of whatever underlying operation you're doing. If you're doing some sort of like scheduling, like giant distributed scheduling problem. And so like in a lot of those cases, I actually care a lot more often about the number of like basically like reads that are not going to fall in the same cache line than I do about like how much like than I do about like the cost of a single allocation, because like a lot of times my allocations are like very nicely amortized anyways, um where it's like, yeah, when do I allocate, when this like particular like hash map or whatever or like slab or something grows every once in a while, and that's when I allocate. But like the like memory related concern that often pops up is like, okay, well, like I'm now doing like a new read for like a like I'm like following a pointer around or something, and like that often tends to be like, for me at least, is like often like the more expensive thing. And so like there's a lot of cases where like I'm just like, yeah, I'm just gonna copy more data around, or I'm like gonna like hold more data here, because like that way I don't have to like, like that way like I don't care if I'm like allocating more memory now, like I am jumping around a lot less. And so like that can often be like pretty useful to do.
Okay. And then maybe like a last question I have is like, okay, for now Pingora only supports like HTTP 1 and 2, but I know you said soon you will probably maybe do something based on your other work you do in that area. But in the meanwhile, as far as I know, maybe I was wrong, I do think you can, I mean, because like a browser will anyway like do H3. Is there something then within Cloudflare is terminating the H3?
Yes. So
Yes.
this the other interesting difference between like Oxy and like between like Oxy and Pingora is like Pingora is a lot more origin facing. Um and like indeed like once you get to the entire like, cache and origin fetch and like the whole origin facing part of the stack, that's all Pingora. But Oxy, because it was dealing with like these like tunneled connections and was dealing very early on with things like Quick, um for like using mask to do like that type of proxying, for example. um the like Oxy ended up basically be like building out this like a bunch of like H3 like ingress facing type support. And so like Oxy like has like an H3 server. And like this has actually been open sourced in the form of like Tokio Quiche, which like is like Oxy like grew out of Oxy as the like built on top of Quiche as the like H3 implementation. And so like the like that is like what we are using under the hood for the like ingress facing part of the stack. So right now actually like we use Quiche with NGINX is what's servicing still like most of our ingress facing like traffic. Like that part of the stack like is not as oxidized and rusted as the origin facing part yet.
That's cool. Okay, so that answered that question. So then maybe the actual last question is like, I know, Noah, you have like a very cool t-shirt about Pingora. Our listeners cannot like see it. Is where can we get a nice t-shirt like that?
I don't know if we have a channel to merchandise.
I was about to say I was about to say like we should do that.
We honestly, I think we are a team that really that has a lot of like different responsibilities at Cloudflare. We're really, we really love the Pingora community, and like it's really, I think it's been as the response is both overwhelming and also like not super overwhelming for like maybe a standard like open source contributor who has really dedicated focus time. But like I think we just wish that we had a little bit more bandwidth to look at open source things from time to time. And in doing that, like to that end, I think, like if there was, we would probably want to be fostering more of that community, and selling t-shirts, I suppose, or, just getting in touch with more, folks using Pingora. 'Cause, we don't necessarily know, like when people talk about using Pingora, like oftentimes it very much comes to us as a surprise, right? And, maybe we want to do more with that in the future if we have the capacity to do so. We would certainly love to do so, but yeah, I guess we'll see. For now, I know that only we have these shirts. Unfortunately.
Maybe I should like get a stack of them and take them to Tokyo Conf.
Yeah. Yeah.
Maybe that will happen. Maybe
cool.
that will happen next year.
That would be
Okay,
cool.
so we all heard it. Noah is gonna bring a stack of t-shirts to Tokyo conference. That is definitely promised. So anyway, on a more serious note, I do want to thank you for your time. I'm sure you're both very busy, and so I'm very grateful. I mean, I learned a lot. I'm sure our listeners will learn a lot. We will link to a lot of the resources we discussed today. And of course, if you both have like resources you want me to share, definitely send them my way after the recording and we will do that.
Thank you very much for having us.
Thank you so much. It's been a pleasure to be on.
Netstack.fm is brought to you by Plavayo, building secure, open, and resilient infrastructure with Rust, protocols, and purpose. This show is also made possible by Rama, the open source networking framework. Plavayo offers service contracts and welcome sponsorships to keep building and supporting its ecosystem. The theme music of this podcast was composed by DJ Mailbox. If you enjoyed this episode, don't forget to subscribe on your favorite podcast platform and leave a 5-star review. It really helps others discover the show. Thanks for tuning in. We'll see you next time for the next handshake.